Welcome and thank you for joining. We'll take a look at question number 28 on page 113. So as you can see here, we're trying to find the derivative of each function, and we have examples of functions given in product or rational form, which means that to differentiate them, we have to use either the product rule or the quotient rule in differentiation. In addition, if you notice here, we have a lot of chains in many of the factors or in many of the terms, which means that again, we have to keep in mind we have to use the chain rule as well. So just to start with question A, we have a product. So the formula for the product of two functions when differentiated will have the derivative equal to, so remember how we write this. So we write FG and then GF. So the order doesn't matter, obviously, but it's kind of nice to remember the pattern and always to write the derivative first. So that would be the derivative of F. Here would be derivative of G and then plus in between. So we'll start with example A. And first write down the question. So we have the function f of x equals 2x minus 5 to the power of 3 times 3x squared plus 4 to the power of 5. So again, we have the product of two functions, which means that we have to use the above mentioned rule here. So we'll start off by differentiating 2x minus 5 to the power of 3. And I'm just writing the steps. So I'm writing the product rule in differentiation for the equation. I'm not differentiating yet. So that would be the derivative of the first factor multiplied by the second one. So 3x squared plus 4 to the power of 5. And then we have plus. We take the derivative of the second factor, which is 3x squared plus 4 to the power of 5. And then multiplied by the first factor in the function, which is 2x minus 5 to the power of 3. Now let's get to work. So as you can see here, we have an outside function, which is the power 3 function, and we have an inside function, which is a linear function. So when differentiating this, then we'll write first, or we'll differentiate the outside of it. So we have 3, whatever was inside, raised to the power of 1 less than 3. Remember that 2x minus 5 is not changing. And then we multiply by the derivative of 2x minus 5. And the derivative of 2x minus 5 would be derivative of 2x, which is 2. And then minus derivative of 5, which is 0. But 2 minus 0 is equal to 2, so we don't have to write the term of the derivative of the other term. So with this, we have differentiated this part of the expression only, which means that we now have to multiply by 3x squared plus 4 to the power of 5. So here we go, 3x squared plus 4 power 5. So next we are differentiating the second group of terms here. Remember that power rule has two groups of terms. So we have the derivative of the outside first. So the outside function is the power 5 function. So we have a 5. And then 1 less than 5 is 4. And then here we have 3x squared plus 4. So again, the inside doesn't change. And now we'll take care of the derivative of the inside function. So derivative of 3x squared is 6x. And derivative of 4 is 0. So 6x plus 0 is still 6x. So we'll leave it as is. And obviously, as you can see in here, we have simply differentiated this factor. And that's what it equals right here. Which means that we now have to multiply by 2x minus 5 to the power of 3. And now let's clean up the expression a little. Remember that monomials can go together, which means that numbers 3 and 2 multiply. That will make a 6. And then we have 2x minus 5 power 2, 3x squared plus 4 power 5. And then we have plus. So monomials again can multiply. So here we have a 5 and a 6x together, 30x. and then 3x squared plus 4 to the power of 4 times 2x minus 5 to the power of 3. So next we have to simplify, and to simplify means to write the derivative in most simplified and factored form. So what that means is that we won't see anymore a group of two terms added to each other, but we'll see a bunch of factors multiplying each other. So we start off with inspecting the factors that are in monomial form. So we have 6 and 30x, and the common factor of 6 and 30x will be 6. So next we look at the binomial 2x minus 5. So 2x minus 5 is to the power of 2 here, and 2x minus 5 is to the power of 3 here. So as you can see, 2x minus 5 is a common factor. So we'll list this as a common factor. And the power that we can take out is the smallest power. So between 2 and 3, we're choosing power of 2 here. And the next term that we have to inspect, or the next factor we have to inspect, is 3x squared plus 4. As you can see, it's present in both chunks of terms here. And that means that 3x squared plus 4 is a common factor. And now we inspect the powers. So we have a power of 5 and a power of 4. So the smallest power can come out because the smallest power is common to both factors, or to both groups of terms. And now we have to figure out what's left from each group of terms here once we take out the greatest common factor. So number 6 is out, so there is nothing left in here. 2x minus 5 power 2 is all out, so there is nothing left in here. And 3x squared plus 4 power 5, we have 4 powers out, so 1 power is in. So 3x squared plus 4. And then next we inspect the second chunk of terms here. We have 30x, 6 is out, which means 5x is in. We have 3x squared plus 4 to the power of 4. The entire factor is out, so there is nothing left from this. And then we have 2x minus 5 to the power 3. Now 2 powers of 2x minus 5 are out, which means that 1 power is still in. And remember, it's still multiplying this monomial here, or whatever is left of this monomial. And now we'll simplify a little bit more. So we have 6, 2x minus 5 to the power of 2, and then 3x squared plus 4 to the power of 4. Now, inside brackets, we have 3x squared plus 4 plus 10x squared minus 25x inside the brackets. And let's see if we can simplify any further here. So we have a 6. We have a 2x minus 5 squared. We have 3x squared plus 4 to the power of 4. And here in brackets, we have two like terms, which will join each other to make 13x squared minus 25x and then plus 4. And voila, this would be the derivative of the function f of x. Now we're going to say is in factored form because whatever we see here is, multiplying the other factor. So it is completely factored and completely simplified. We don't see any terms actually that we can take out. And another question that I get asked very often is, do I still have to factor if I have, let's say, a trinomial of second degree or a third or a fourth degree polynomial? So in this case, I would say that if it is a second degree, obviously we want to check and see if it is factorable most of the time, especially when you solve word problems and you want to find the zeros of each factor. But if it is a degree higher than 2, at this point, when we're working on derivatives of function, again, unless we're using them in word problems, we don't really have to look on factoring those polynomials because that is another big exercise on its own. And what we are focusing on here is practicing differentiation. But obviously, if just for the fun of it, and if you wish to practice and review the factor and the remainder theorem, go for it, I would say, and have fun. So I hope that this made sense, and I hope the instructions were helpful. And thank you for learning with me. Bye for now.